First, let's take a look at why the question of open versus closed came into the picture in the first place. Building design, documentation, and construction were traditionally sequential processes. Due to changes in technology and the increased competition on the AEC market, the time allocated for projects significantly shrank, and as a result, processes became more and more parallel to comply with the increased demand. A few decades ago, projects were designed and delivered using blueprints. In these paper-based workflows, coordination between the different trades was a manual process, the light table being the only technology implemented. Computer-aided design, or CAD, didn't change much in this process. XREFs were only more efficient digital light tables, but the coordination workflow was still based on matching 2D lines and fills. Simple file compatibility between the different 2D applications was more than sufficient for such a coordination process. With the widespread use of building information modeling, or BIM, model-based coordination is expected to be the norm. The only issue is that coordinating intelligent BIM elements is a completely different story than coordinating 2D lines and fills. Now let's see why. BIM provides significant advantages for the AEC industry, yet it also raises some issues that were unknown in the conventional collaboration processes. For example, different project members working on the same building often require completely different types of data about the same building. For instance, columns for architects are typically interpreted as single longitudinal elements, even in multi-story buildings. Structural engineers, on the other hand, interpret columns as parts of the load-bearing scheme of the building. As a result, they need to split at each building story. The same applies to slabs. For example, while architects may only be interested in composite layers, structural engineers will need to know and model the details of the load-bearing elements. It should be clear by now why simply converting each other's BIM models won't help a lot in the coordination workflow. Another issue to be resolved concerns the various regional standards, conventions, languages, and applications developed by different vendors used by AEC professionals all over the world. There cannot be one single solution that addresses all the requirements for every professional in every region. The contrary is in fact true. The sole interest of the professionals is to use the best global or local BIM solution available for the given task or purpose in every project. As more and more AEC professionals implement BIM in their practice, there's a growing need for a reassuring solution to the previous issue. In 2010, McGraw-Hill Construction conducted research across Europe about BIM implementation. The #1 request for improving BIM was to improve interoperability between the different software applications. The American Institute of Architects, or AIA, similarly declared support for open standards in 2009. Now let's see how these conceptual issues are being addressed through open BIM workflows. As we saw, there are conceptual differences in what type of BIM model the different building professionals require. To provide the basis for necessary coordination between these BIM models, we need to implement the following 3 simple concepts. The first concept of open BIM collaboration is the so-called reference model concept. In the open BIM workflow, BIM models of the different trades are not open for editing by the receiving party, only referenced for coordination. This also mirrors the real-world setup where parties carry full responsibility for their part of the project. Hence, they also require full ownership of their BIM data. The first benefit is clear ownership of models. Everyone can maintain full control over their part of the BIM model. The second benefit is that the focus is on workflow compatibility. As a result, it's easier for professionals to participate regardless of their BIM software. The third benefit is that change management is much more easily provided due to workflow-level compatibility between the different parties. The second concept of open BIM collaboration is based upon model filtering and classification. The BIM model being shared with other disciplines should always meet the requirements of the receiving party. For instance, the structural or MEP engineer may not need the entire architectural model for their work, only relevant elements and information. Here, model filtering ensures that only relevant elements are sent to the other party, while model classification ensures that the information sent will be perfectly interpreted by the recipient. The third concept of open BIM collaboration is the active support of change management. Real collaboration workflow is bidirectional and dynamic, meaning there are continuous round-trip iterations. To fulfill this requirement, Open BIM collaboration offers workflow-level support for change management, where existing, new, modified, and deleted elements are intelligently handled, and the updates are clean and lean in terms of the information inside, the size of the data package sent, and the way the receiving party handles these changes. As you can see, the open collaboration workflow is based on a handful of simple principles that can be applied virtually between any two BIM solutions. Let's now summarize the 5 main requirements of the open workflow. System independence. The open collaboration workflow must work regardless of the actual software application being used. Workflow transparency. The collaboration workflow should be clear to all members, regardless if they were members of the project from the start or are just joining. Ownership of the BIM data. Just as in real life, different trades need to be able to take responsibility for their part of the BIM model. Information classification. It's necessary for the information to be provided in a way that is easily interpreted by the receiving party. Reference model concept needs to be applied to ensure the above requirements are easily being met. As a result, the Open BIM workflow turns technology into a solution. It's important to note that Open BIM is more than IFC. While IFC as an open standard is a mission-critical component to Open BIM, an active engagement between the different stakeholders and participants in open collaboration is also required. Open BIM per se can only be an inclusive system, providing accessibility to any participant in the project who wants to sign up.